present this tutorial on creating science gateways or HPC portal on OneSciencePlace Platform. And what we'd like to do is walk you through from a high level to more of a hands-on view of things and give you a flavor of what OneScience Platform can do to enable this kind of capabilities for you or for users or for the community which you are trying to target with this sort of infrastructure. I'd like to give a shout out to my co-presenters, Chun Han Yoon and Mona Wong, who would be helping us throughout the tutorial. And all of us are at the San Diego Supercomputer Center at UC San Diego. Okay, so here is how we look like sometimes, and feel free to grab that email, and if you have any questions later down the road, feel free to send that to me or to one of, let's see, let me show what the agenda looks like. And this is also posted on the website. I think the idea is that we'll provide you a kind of a high-level view of the platform, then kind of give you a flavor of how to run applications on the gateway, which requires you to log in. So again, highly encourage you folks to kind of figure out that username and password and log in. You should be able to log in from a, use the system from any web browser. You can try it through a mobile device. I don't know how good the experience is going to be, but it's possible to do that as well. And then go over other parts of the platform and describe those at a high level, and then show what they mean and look like, and provide some backend information about all of these things. So that could be systems, that could be applications, which we just call apps. And then idea would be to kind of provide a simple example of how to create an app and a custom UI for it on the system. And we'll try to see if we can get to the part of adding a new compute system. If not, we can review on what we already have. And lastly, we'll want to kind of cover a portion on how to publish artifacts on a gateway. So these could be, these could be data, these could be, reports, these could be, these could be, technical reports, or these could be abstracts, posters, and, things like that. And then finally, we'll spend some time for discussion. Hopefully, we'll have some time left by then. So we have a fairly packed agenda. Okay. All right. So let's kind of go back, and I want to mention a few things here. So, so the OneSciencePlace platform is a platform by the Science Gateway Community Institute. This was in response to the feedback that the SGCI got from the reviewers and from NSF. So that's the kind of the genesis of this platform. And you'll see that there are 4 contributing institutions for this platform, and you'll see there are a lot of folks that have contributed to this platform already, and I think we are seeing more contributions come in as we kind of continue to develop the platform. So I want to thank the contributors and also the sponsors, which includes NSF and other gateways and SDSC, which has funded this work and are continuing to do so. All right. So I think just the kind of a high-level view of things, I think science gateways and high-performance computing has been focused on computing. And the idea is there is a central resource and which is accessed from different places, different devices and things like that. So computing is the center of more or less anything, which is true to some extent. However, for the users, what they do with computing matters quite a lot more. And these things have been kind of been on the periphery. And the idea is that from a user's point of view, it's the things why they do computing. And these things we would want to kind of refer to as content. These could come in, data, it could be files, videos, images, analysis, applications, scripts, visualizations, and so forth. And this content is really the key why anybody is interested in computing to begin with. And the idea is that, we can use the World Wide Web to kind of do these things. And this has already been kind of the case from the genesis of the web, that the idea was that, the web was created to share things, what people know with each other, and do things with them. In addition to the web aspect of things, when things are shared on the web, there is a host of technology that is available that can make sharing of information really, really useful. And the commercial world has done quite a bit on this side, but the academic world has lagged in this area quite a bit. So the search engines and other places have kind of developed a host of technologies to make the content readily distributed at a scale which is, really, really fascinating. And they have done it in a way that scales, it works at a large scale in a very distributed fashion. And at the heart of it has been the meta tags in HTML, but also later on, schema.org came up with this vocabulary, which the commercial world uses heavily. And I think the scientific world hasn't used this so much. I think there have been some starts in this area, but it hasn't kind of gotten to the scale where the commercial web is. Also, this notion of FAIR, which came up in 2016, kind of talks about these principles of findable, accessible, interoperable, and reusable. I think these are great principles which got summarized in this form or fashion, but they have been long thought before. And this encapsulation can actually be implemented with some of the technologies that is already available instead of building something new. And that's where things are heading, and we want to exploit those kind of things. And we want to bake in all these kind of things in OneSciencePlace by using the infrastructure that is already available and only innovate and build on pieces that are missing that we need. So from a OneSciencePlace standpoint, we kind of think about two things. We think about what is content and how we can compose that. And so the idea is that can we create a platform which is content-centric, yet composable and available online that can deliver fair content with integrated computing in a single and easy to use environment. And that's kind of the high level pitch for OneSciencePlace. And the idea is if we can do that, we can accelerate community building and deliver tools, data, and other artifacts to the scientific community at scale with speed. And if we can measure the impact for these things, the idea is we do this at a reasonable cost that the academic community can support. So just a quick background on when we went about building this framework. We wanted to pick a foundational framework that was already proven. We were not trying to build the foundational framework from scratch. It already had a large community that was supporting it. It already had an ecosystem that was supporting that framework. It had a good track record of security because this being an online platform, that is paramount. And then it provides the ability to compose and build and extend that framework. And if you look at these things, while there can be many platforms that emerge, but there are actually very few that kind of are left once you start to kind of put some numbers around these things. So in our case, when we kind of looked at various platforms, we identified Drupal as the foundational framework that satisfies many of these components by a very big margin when compared to other platforms. So that's the platform we ended up choosing to build OneSciencePlace platform on. And so anytime somebody wants to build a gateway or a portal, there are a host of issues that come up. And the idea is to reduce or eliminate this barrier as much as possible with OneSciencePlace. So from having really the expertise to build the infrastructure, how to piece together different components, how to deal with access requests, how to build interfaces, how to run the system 24/7, and how to provide support, and do that with a view that we kind of deduce the total cost of ownership. Many times we build these platforms without really knowing what the total cost of ownership for these things is. And that becomes very, very expensive in the long run to do, or not even known that when you set out to do these things. So that's kind of the idea, that we want to reduce or eliminate these barriers for people who are trying to do these things, and support them and enable these kind of interfaces and things like that. So I mentioned composability, and this is again a generic word, but let's kind of define this a little bit in this context. In this case, we mean composability, that the architecture for OneSciencePlace is modular. It also has available components which are available from third party, and not just everything needs to be built from scratch. Again, the idea is that we can build custom components as needed for discipline, resource, or community. Then there is a ability to do content management in a really a very well-structured yet composable way. Then the idea is, can we plug in data and compute onto the system as we kind of move along? So you can start out with some resources, but then at a later time, can we kind of include others, or can we include more than one resource? That's kind of the idea there. And more importantly, while all these things are great to have, ultimately you are looking for a solution which actually meets the need that you are trying to kind of address. So the solution needs to be very, very well defined and very focused on what the needs are. And to do that, you need all these pieces on the left side to be able to accomplish those goals that you are trying to accomplish. And many of the batteries that we need for these kind of things are going to be common. And that's the thing that the OneSciencePlace platform is trying to address, and build that core capability, or the core set of features that will bring up things to maybe 75, 80%, maybe 90%, and then the 20 or 25% or less is the custom piece that a community or a portal needs. Of course, that will vary from application to application, but that's the idea. So let's talk about some key elements of OneSciencePlace. So in OneSciencePlace, we have a notion of apps or applications. These are software applications that can be deployed on the platform. Then we have notion of the data that comes with either input, output, or curated data that may be hosted. That ties into publications. So the idea is to enable first-class publications on the platform that will include your persistent identifiers in different shapes and form. We can talk about that in a little bit. And then the idea is that can we create ability for people to create projects so they can work in groups and share information with them, applications, data, other artifacts that they need to do in course of research or teaching. And then lastly, every project typically has a website, and in this case, gateways tend to have fairly complex websites. Portal tends to have fairly complex website. Can we support those kind of things as well? And then we want to kind of look at how do we do user management and access management, layer all these things on top across all these places, all these pieces on the top, and provide open or restricted access for the artifacts that warrant that kind of access limitation or openness. And then we want integration of remote computing resources or on-premise resources as easy as possible. And lastly, start to measure the impact of the contributions in various ways, and then make that available to the users and to the stakeholders, and also to the sponsoring agencies, then what this is enabling. And I think this is one of the weakest area in any of these infrastructure, that while many of these things get constructed, but they don't really get to the phase of impact measurement in a significant way that can really articulate the value for stakeholders, what these things are actually accomplishing for the community users and the resource providers. So just an overview of the platform itself. You start with the hardware layer, then you have a bunch of stuff that really does the orchestration of different pieces of how to use that hardware, how to do the DevOps portion. Then you have the backend layer, which has a bunch of servers and things like that really index and serve the information. And the top layer is the application layer, which actually looks like a portal or the gateway. And it comprises of various pieces of technologies and that we have not developed, but are available to us from the community, either the open source community or our scientific community. And we are using and leveraging those and composing these in a way that they are seamless to the user and to the stakeholders. Okay, so some established use cases for this sort of framework is, that we already know that science gateways are established use case. We know that the HPC portal or computing portals are another use case, but there are other emerging use cases or that we see. There are sometimes fairly complicated applications that require this sort of access, and that requires user management, data management, and control access to computing and who can do what. There is a need to create these data repositories, and I suspect that this is an area where we may see some growth with the Nelson mandate kind of putting a time frame on when the research artifacts from federally funded research needs to be really available in an open basis, not just the manuscript, but also the data and other artifacts that were used to produce that manuscript. So I think this kind of need will emerge, and I think we'd want to kind of address that sort of need as people start thinking about those kind of things. And similarly, there is a notion of creating these knowledge bases, whether for a particular community or a discipline that makes sense for people to gather around and have this information available readily. And then there is a constant and a new trend about emerging challenges, and we see the word AI kind of being floated around quite a bit, and it mixes nicely with the HPC side of things because the computing requirements are significant, and we want to kind of see where we can support those kind of use cases and make them available to a wider range of people than possible currently. So we have several projects that have committed to the platform, but there are several pending ones. We are building a couple of gateways and a couple of other portal-like things for different communities across US, and we are very interested in learning about what you may be thinking about and where this sort of platform could potentially be a fit for your work. So again, to kind of summarize, I think the platform really targets kind of creating easy to use infrastructure to democratize computing content, remove the barriers for expertise, resources, and provide a way to amplify impact for the user, and then do that in a way that minimizes the effort on the stakeholders' part and also the costs associated with doing so. Okay, so let's kind of switch gears here and see if we can jump on to a few of the components. And I'll start to kind of give you a flavor of things here, of what the platform does, how it works, and I'd welcome you folks to try it as we kind of go along. Let's see. Okay, so before I actually jump onto the web browser mode, let's see if I can share one more thing here. Okay, so I'm going to log on to the website. Most of the times you'll see in a mode that kind of looks very similar to what it will for you if you're logged in. So you'd see the left panel sidebar kind of pop up. You will only see this if you're logged in. If you're not logged in, you will not see this. But sometimes I'll be switching around and going to an admin mode. And when I'm in the admin mode, you will see this red toolbar. I will not try to do many things here with in the admin mode, but I'll be switching around. So whenever you see this red toolbar, I am in kind of an administrative mode and I'm just switching around things. So it's kind of, you know, I'm doing this as a convenience so I can move around a little faster. Hopefully I don't have to do it too many times. But that's kind of the two modes I'll be kind of sharing my screen and, you know, working through the system, through the tutorial. So let's kind of switch around and move to the website. Okay, all right. Can you folks see my web browser?
Yes.
Okay, good, thank you. All right. So just to kind of situate you folks, I'm going to switch around as me. I have a handy way to kind of switch around here. Okay, so if you go to the website, you will see a few things. If you're logged in, you'll start to see this left toolbar. But if you're not logged in, you would see, you know, the top menu, which is called apps. Think of this as an app store or the app store for this tutorial. The idea is that, you know, these apps can be created and then made available site-wide, or they could just be restricted to your own use. So they could be personal apps as well. Then we have a notion of publications. We'll cover this a little bit, but just to kind of give you a flavor of that. And then we have a fairly, you know, simple help section for now, which describes different components. And I'm hoping to cover most of these things. And then perhaps get into one of the hands-on portion, which is a tutorial on creating an app on the gateway. But there are a couple other tutorials which are fairly simple, and I don't know if you'll get enough time to cover those, but I welcome you folks to kind of try that later on. They are all documented here. Okay, so let's kind of take a look at the apps. So app is nothing but a software application that is already pre-configured to kind of run on the gateway. It is an application is always matched to a system where it will run on, and it already has all the necessary ingredients that it needs to kind of be ready to use essentially. So maybe that's a good place to kind of start. So if you're logged in, what we can do is try to run a couple of these apps and see what they look like. And then before I jump into apps, I want to kind of show you what an app essentially means. Let's see if I have it here. No, I don't have it here, so I have to go back to a slide. And let me switch to my slide here real quick. So on OneSciencePlace, we support 3 types of applications right now. We support web applications. Web application would mean something like Jupyter, RStudio, or other application that have a web front end essentially, or you know, are basically serve a HTTP context essentially. So that would classify as a web application. Now they can be very complex. We support certain types of web applications, so I want to be specific there. We can support VNC applications. These are essentially your desktop applications that can run on Linux host. So Linux desktop is one example, or MATLAB would be another example, but there could be other examples like semiconductor EDA apps and things like that that have a fairly complex application setup, so those can also be run. And the third type of application that is supported is a command line application that essentially, you get an interface, you launch it, it does its thing. So that's not interactive. So the first two are interactive. The last one is not interactive. And I'll just mention this here for now, but we'll come back again to this. There are a few requirements when constructing an app. Like if it's an executable, it needs to have a single entry point and it should take all the arguments. And I'll cover this again. If they are in a container, so the two types of containers that are supported right now is a Docker container and a Singularity container. And if it is a container, the container should make the fewest number of assumptions in creating those applications. One of them is like if it's a web application, it should not hard code the port on the host side, and it should not hard code the volume mounts, and those should be customizable. And if it's a VNC app, then it should include a VNC server and provide a way to set a password so it can be securely accessed by other users. So we can look into these things a little bit later, but kind of give you a frame of reference how these apps were constructed. So let's switch gears and kind of see how they really work from a user standpoint. So if you kind of go to the application menu, you'll see, you may or may not see add app, but you'll probably see all applications. You'll probably see my applications because we have given privileges for almost everyone to create an app on the tutorial website. So here we see there are different applications that are available. We have two variants of Jupyter application. One of them is called the web app, and it's going to run on AWS, a Linux host that we have set up for running these apps. But we also have one application called Expanse Jupyter Notebook, which is running on Expanse SDSC. So this is a SDSC cluster. It goes through a scheduler and it will run there to kind of give a flavor for that. So maybe that would be a good place to start. So I'm going to start with the Jupyter app. So if you go to the Jupyter Notebook app, if you click on Launch App, you'd see a web form that will appear. And we have kind of made all these things read-only, but we can really make these customizable. But for the purpose of tutorial, I think they are just read-only. So a Jupyter Notebook in this case requires a password. I'm going to set up a password for this one. So when you kind of go and open up that Jupyter Notebook, since it's available as a URL, anyone can access that. A password really secures that to a next degree. So you can set up a password for that. And once you kind of launch a job, it goes through different stages. And then once the application is ready, you would get a button here to open a session. So if I'm going to open that session, sometimes you'll get that page not found here if you kind of get in here a little too early. There's a lot of wiring that is going on behind the scene to kind of make this work. You can just refresh that page a few times and it'll show up in a few seconds. So I added a password to this Jupyter Notebook. Once I go in there, start to see the Jupyter interface here. There it is. And then you can kind of go about creating a notebook. I click that, and there it is. And go about kind of, adding your data or, doing all the things that one would do on a Jupyter Notebook. Let's see if it comes up. Okay. So let's just do our obligatory hello world in there, and nothing too fancy there. The idea is you can go about doing all the Jupyter things in there, and that's essentially a flavor of running an application on OneSciencePlace. So you'll notice that every application essentially gets its own unique URL. And this is all plumbed in behind the scene, and it runs on the host, and we create these URLs which are secured with a SSL certificate and all that. The application doesn't necessarily need to know all that stuff. We do that plumbing behind the scene. So you can just bring in your vanilla notebook, and it can be run here in this environment. Once an application is running, it will obviously get killed after 10 minutes, but if you wanted to terminate it early, you can just click on this terminate button, and it will keep showing you it's still running, but actually it has just been queued for termination, and it will basically terminate that app behind the scenes and then show an updated status. Sorry, my screen just paused there. Are you able to still see my screen?
Yes, we could see it now.
Yes.
Perfect. Yeah, so I just terminated that job. Let me see if I can. Yeah, so I killed that job, and then you are no longer able to access that that link. You also have an ability to share the session, and since I just killed it, I can't create another link. But if there is a way to create another link which you can pass on to others if they wanted to look at it, but they will see a different view. That depends. This is more useful for VNC applications than for Jupyter notebooks, which basically have a new context for each window. So let's kind of move back and maybe run the Linux desktop as an example of a VNC application. So right now we ran a web application. Now we can try to run a VNC application. Process is the same. Essentially go and launch the app. Again, we have configured a way to set a password for a VNC session. So if anyone even has the URL, they will not be able to access the application. Again, you can see the resources. Those can be made user customizable, but we have made them read-only. So again, this will go through the different stages to launch the VNC application. Behind the scenes, the VNC application is a container that has a VNC server, and it fires up that VNC server and has a Linux distribution that is available, and it mounts a directory in that environment that is available to you. I think in this case, the this application is, again, a Linux desktop, but I think the way to think about this is you would want to probably run a more capable application here with VNC, such as, a MATLAB or any other applications that are native to Linux. So here we have the VNC server starting. It takes a few seconds, and then it'll prompt us for password, and there we have our Linux application going on there. So again, you'll notice there is a URL there, which is again unique to this particular application, and this entire plumbing is being handled behind the scene by OneSciencePlace on where it runs the container, how it generates the URL, how it kind of tunnels the traffic, converts the SS tunnels into HTTP. So there's quite a bit of plumbing going on behind the scene, and that automatically handled by OneSciencePlace. So there's a proxy running behind the scene which does all that work. Okay, so that was a quick kind of a view of a Linux desktop VNC application, and this is what I was talking about. If I wanted to share this application session, obviously I can give this link to somebody, they can share it, but I can also construct another link here and share this with others, and they will have access to it. And then, when I'm ready to revoke this connection or revoke their access, I can just delete that link, and then they won't have access to see, I deleted that link, and then that connection is no longer available. So it's kind of handy if you wanted to kind of share your VNC session with others. Okay, so let's go back to our job here. So a job is running. You can again go ahead and cancel this job. Once the job is canceled, it won't be available through that unique URL link. We already saw that. I'm going to pass on that. So we saw an example of a web application and a VNC application. Let's kind of take a look at a batch application now. So here is a simple application. Let's kind of run it. And all it does, it takes two numbers and an operand and kind of, writes the result of that operand into a file, right? So I'm going to give two operands, and then I'm going to say that, hey, write the output of this thing into a file. I think the application is obviously trivial, but think of it as an MPI application. Think of it as any other application which take a bunch of arguments, and then the idea is to create this kind of a user interface and make it available to the user to run those applications. And so this application is already paired up to run with this Linux host, and we can give it a job name and submit. And then again, we have made all the resource requirements read-only, but of course you can, depending on the application, those can be made available to the user to change them. And we'll see a flavor of that in a little bit later. So now this application is running. It's going to go and do that fancy calculation. And when that job is done, it's going to go and say that, okay, it is done. And then when this job is running, we can go and see what it is doing. So it has already created these, various things it needs to actually run the job behind the scene. And we can browse this thing. I suspect this is already done. Yeah, it's already done. So I can go ahead and download the data. And if I download the data, it just downloads as a zip file. And if I go and look it up in my computer, let me see if I can show my Finder here real quick. Are you able to see the preview when I open a file, or you cannot?
It looks blank.
I mean, output.txt.
Okay, but okay, I think I may have to share my desktop actually for a moment. Are you folks able to see my desktop?
Yes.
Yes.
Perfect. So here is the output, the text, and voila, we have 125 as the answer. And this application is pretty simple. All it did was, took two arguments, multiplied something, and wrote an output to a file, right? So you can see the output. So you can download each and any individual file or the whole thing. Now, I think this thing happens quite a bit. Oftentimes, researchers would want to run an application again. And then, so we have an option to clone a job. What clone a job does is OneSciencePlace stores all the information that was used to actually run the application. It is all stored. And what we can do is we can bring back and clone that application. So think of this as maybe a climate simulation or a CFD simulation, which has several different parameters. And now you want to run that simulation again with maybe slight tweaks to some parameters. And so you can go back and clone that application and run it again. And every time a job runs on OneSciencePlace, it creates a unique folder where it will store all the logs, all the inputs. It will stage all the inputs there. It will put all the outputs there, however the app is constructed. But everything happens in that context of that folder, right? So they are the app needs to be fairly self-contained. They shouldn't be trying to write all over the place. That is an important thing, because that can obviously create issues with security. It can create issues with writing in inadvertent places. And so the idea is that all applications need to be able to be limited to writing to few locations, fewest as possible. So that's kind of important security kind of angle which you have to think about when you are kind of deploying these applications on any online platform, not just OneSciencePlace. So, okay, so we ran another application that finished too. So we can go ahead and download this one again, and then we should be able to see the output. So I'm not going to go ahead and show you those files. It's a trivial example, but the idea is that we can run these applications like this. But just for kind of giving you a flavor of these kind of things in a little bit more real sense, we have another instance I'm going to log on to that we are using for migrating the Cypress gateway. I'm going to give you a flavor of a real application which runs on Expanse. And so here is a phylogenetic code which does some analysis of, so I need to log in as Mark, I guess. Let me see if I can give you a flavor of this thing real quick. Yeah, so there we go. So here is an application. It takes an input file. I'm gonna add an input file here, and then it has a bunch of these parameters that needs to be set, and these can be conditional, and it has this user interface has been constructed to kind of be responsive, or it's paired with whatever the application needs behind the scenes. And then in this case, there is an ability to control how much runtime somebody may want to specify. But then in this case, the resources are automatically selected because the Cypress teams know when, depending on what input is there, what kind of resources it needs. So there's a little bit of intelligence that has been baked into the application in selecting the node cores and the queue, and that part is not made available to the user. The application takes care of that. And then you go ahead and submit this application. So this will run on an Expanse cluster. This will take a while, and it runs in the same way as the calculator app. But you can see that in essence, what is happening is this application is actually constructing these command line parameters that the application needs and sharing it with the runtime, which will actually then actually go about computing these things. So all this is constructed on the Science Gateway. So while that is running, I'll just kind of give you a flavor of this here for now. And this is going to be a little bit heavy to absorb, but just to kind of give you a flavor of this thing, this entire user interface was constructed using a user interface on OneSciencePlace, so you're not coding, okay? And we'll try to do this later on, but all this stuff is constructed using the elements that we have available on OneSciencePlace for, providing, numbers, text boxes, select boxes, conditionals, things like that. All this is constructed using a user interface. It takes a little bit of time to kind of construct these things, and we'll go about creating something simple a little bit later, but I just wanted to give you a flavor of what this looks like. The user interface can also be, it also generates YAML behind the scene when you construct it through, the WYSIWYG interface. So once you kind of, if you want to kind of use the YAML input, you can copy and paste and just use that YAML to kind of create these fairly complicated interfaces on the gateway itself. So just to kind of give a quick preview of what we will discuss a little bit later. And then there's a whole setup there that when you're building this thing, you can test these web forms and things like that before you actually make the application available for running. So that is kind of a quick context of a real application that we have several of those. I think I showed you one which has a few dozen parameters. I believe there is one for Cypress which has 200 parameters. So all that is kind of wired up to kind of do things what the application needs, and it runs on Expanse. But it can, in essence, it can be paired with any cluster, any Slurm cluster. All right, so
Amit,
yes.
there are a couple of questions in the chat that I think you might want to answer.
Perfect.
And then maybe there might be a couple that you might want to save for the end.
Okay, perfect.
It says, There were two questions about persistent storage. Do the apps support mounting of persistent storage?
Yeah, so I think that's a good question. And I think maybe let's save it for later. We'll talk about it when we talk about systems. Yes, it does, right? So I think the persistence of data is not necessarily the attribute of OneSciencePlace, it is attribute of the resource. So whether you have persistent storage or not, that's a policy of our system. So if you're going to compute on a scratch storage, that's the policy of HPC system, right? So that's not something which OneSciencePlace has any control over. If you're going to use somebody else's resources, they tell us what is persistent and what is not, right? I don't know if that answers the question or not. But yeah, if you have a persistent mount, it can be mounted on a system and then made available to the application. So that's certainly possible. In fact, Cypress would be doing that. They are not going to use Lustre. They are going to use their own NFS share, which is mounted on Expanse. And that's how they are going to compute. Okay. So that's Rajesh's question, I believe. Where are those apps running on? So that's a good question. And then can the users run and monitor when their batch applications are running in batch mode? So applications, so we demonstrated 2 applications or 3 applications. 2 of them were running on a Linux host on AWS, and one of them was running and actually we haven't run anything on Expanse yet. But we can run application on Expanse. Actually, the Beast application, which I just showed, is running on Expanse on the website that we have, or instance of the gateway we have. But we also have this Jupyter notebook. You can try it yourself, and this will run on Expanse. And can you monitor the execution of app in real time when in batch mode? You can monitor the output of the batch application, right? So you can go to the output tab and see what has come up in real time and see what has happened. I think that's what probably that question kind of refers to.
There's one more question by Peter about how is the OneSciencePlace hosted? Is it front end, something we could host locally, or is it more of a SaaS model?
Yeah, currently we are running this more as a SaaS model. So we operate and maintain and manage everything, and we customize things with you to work on different resources. Okay. All right. So we talked about apps, and I think these questions nicely segues us to that. Where are these apps running, right? So what we have done is we have configured 2 systems on this instance of OneSciencePlace. One of them is a Linux host on AWS, and one of them is Expanse cluster at SDSC. And so I think there are some nuances here. So let's kind of review these things real quick. So let me see if I can share this. Okay, are you able to see my slide here?
Yes.
Okay. So a system is essentially a hardware resource. It could be a computing or a storage resource, right? So it could be a Linux host or a cluster like Expanse or a HPC cluster. And I think on the storage side, it could be a S3 bucket and things like that. And I think we are still not quite there in integrating all the different kind of storage resources, but we are integrating currently the computing resources and some elements for storage for now. So from our point, for now, the system is essentially a compute/storage resource. For any storage resource, it must allow SSH access without a passphrase. I think there is a discussion with MFA and all that kind of stuff using side tokens and things like that, but that implementation is still kind of at an early stage at this point. So that's kind of a requirement. The OneSciencePlace must be able to kind of access the account with a SSH key essentially. And then it must not block connections from a set of IP range essentially. If there is blocking going on, then those need to be whitelisted. So those kind of are the 2 requirements. for a system. It obviously needs to have some storage, whatever that means, whether it's a mounted storage or whether it's a shared storage or whether it's a scratch storage, wherever the data needs to live. So that needs to be a part of a system. So we have two systems. One is a Linux host, and the way we can configure these systems is there are two ways to configure these systems. Either the system can be configured for everyone in the gateway to use a common account, which is typically common with HPC resources and science gateways. It is also possible to configure a system to use users' own accounts. And I think this kind of modality is more kind of geared towards the portal kind of use case when you are actually running everything as yourself rather than as a shared account. So both kind of modalities are possible. In this kind of tutorial, we have constructed more or less everything with a common account, but the method for constructing things with a personal account is just the same. You essentially, and I think we'll talk about those details a little bit later. So that's kind of a quick view of systems. Okay, so let's kind of quickly review our agenda. So we talked about apps, we talked about compute systems available. We have a Linux app and a Linux tutorial. I already showed you this complex app, the Beast app on Expanse, and I kind of gave you a flavor of the UI. But maybe we can go in and try and construct an application and create a simple UI for it and see how far we get there. And this is all documented, by the way, here. So I'm going to try to do this somewhat quickly, but you can try and do this later on as well. But to kind of give you a flavor of this thing, essentially what is happening is, I think there are lots of screenshots, but I promise it doesn't take that much time to kind of set up an app. So where is the script that actually runs? Okay, all this is doing is there is a script that is available on the Linux host at some path, and it takes few arguments. I mean, this is all made up, right? So first argument is first operator equals the numbers, then an operand equals whatever operand there is, second operator, and then output file. And so this is essentially the idea to mimic an application that has a bunch of arguments, and we'll try to construct a user interface which has these kind of attributes. So let's try to kind of create this. And let's see if I can go about doing this real quick. So I'm going to go to apps. I'm going to go to my apps and add an app. So I get to pick a I like to name my apps like this, but you can name them however you like. Then app supports versions every time, and there's a reason why this is important. Once you create an app, eventually it will, once you publish it, it becomes immutable. And so every time you want to kind of push an update to an app, besides the user interface element aspect, it becomes immutable. And the idea is because if you remember, the cloning of job is tied to an app. If the apps were mutable, you kind of break that consistency between immutable job which ran an app. And so you can always create a new version of an app and make the previous one either disabled or still available for the users to use. So that kind of keeps the provenance cadence going between an app and a job, and for a user to be able to kind of switch between things if they have to. So it's a simple web form. In this case, it is going to be a batch application. There is also an ability to support a restart. Of course, the restart can be fairly complex, but depending on what it is, it may be possible to support it. And in this case, I'm going to check on show generated command option here. In container runtime, I'm going to select an executable path. So the executable path is this. Chunhan, maybe you can paste it in chat if you, or people can just look for, search for path. So this is already kind of copied onto the system. And this system is not going to use a batch scheduler, so we don't have to worry about that. But if it did, this is where you will kind of set up which queue to use and what there are, you know, other modules and things like that that need to be loaded up to run this app. The default system is apps. I think the idea is every app needs to be married to one system. If you do it too many times, it generally is not possible to do that because the paths and things are different. I think you'll have to go to great effort to kind of make it work on different systems. So the idea is one app, one system. You can always create a new variant and for different systems. So the tenant is tutorial. In this case, input type, we are going to create this UI. So we are going to say that the input type is a form, a web form that will take this input. So we are going to construct this web form. And parameters and environment variables, I don't think there are any in this case. It doesn't take any environment variables or any other parameters. So we don't need to specify any of that, but they are available if they are needed. And if you also notice, if you're launching a container, it needs some specific things. You can specify those here. Runtime resources, how many jobs can be run of this type. So you can limit these things by user or globally, how many things that can be run. I'm going to leave all these things to default here because we don't really need too many things here. But the idea is all these things can be specified and they can be made available to the user to change them if there is a need to change it. But in this case, we don't need to make anything changeable here. And then that's it. Chunhan, am I missing something? So I think I only
no, yeah, that's all. Yeah.
So essentially, let me just recap here. I basically went to add apps and created add app. Then I selected, you know, enabled as the status because you can disable an app for some reason if it's kind of misbehaving or kind of done, you can archive it. Provided these kind of metadata information about the name, version, some summary. You can provide description, documentation. In this case, the application is type of application, which is a command line argument. It runs in non-interactive batch mode, so I selected that. I want to see the command that's generated. This is more for debugging purpose. You can turn it off once the app is ready. This is a type of executable. Like I said, the OneSciencePlace currently supports 3 runtimes, Docker, Singularity, and an executable. Then we need to specify where the executable actually lives on the system. And the system is this one, the AWS system. Your system would be whatever you want to call it, or whatever is available on the gateway. And then tenant is something you don't have to worry about. It's always going to be a single value. And then we want to create a user interface. So I'm going to select this option called form. If it was a fixed thing, I'm going to choose fixed and then just enter my command here. If there was no input needed, I'm just going to choose no input. More often than not, you would find that most applications, unless they are containerized, will need forms if they are batch application of one sort or the other, because you'd want to specify or allow the user an ability to specify what those operations would look like or what those arguments are. Okay, so our app is there. Now it's time to configure the app form. So we get a nice message here with saying configure app form. What this means is, okay, go ahead and build the UI for this form. So once you do that, we got some few things that were already kind of the system bakes in for us. It kind of allows us to pick the system. It gives us every job has to have a name, so it adds those fields. And then what we are going to do is we're going to go to this tab called build. If you go to build, and then there we see all these things are kind of listed here. We can move these things around and say, hey, job name needs to be first. And then we can say add an element. And we know in this case we have two operands. And actually, this is a good time to kind of switch over and talk about what are the primitives that are available before we start to use them. And so if we go to applications help here, and this is kind of visually shown here, I'm going to scroll down all the way to the bottom here. Oh yeah. So here are some primitive elements that are available to construct a user interface. So there is a type called checkbox. If you want to create kind of a yes, no sort of thing and do something about it, you can use the checkbox element. And if you want to upload a file, you can use the file element, provide an ability for user to upload a file. You can use the file element. And if you want to create kind of a selection like we will have in this calculator app to create different kind of operand like plus, minus, multiply, and divide, you can choose the select element. A text element would be useful in this application to kind of create the output file name. And then we don't need a radio. Sorry, I mixed up between checkbox and radio box. So radio box, if there were multiple options and you only wanted to select one or the other, we'd kind of use the radio. And we would use the number field because we'd want to enter some numbers for the calculator app. So we'll use the number UI. And then there is something more advanced, which is like if you wanted to do some conditional, if you found this value on this UI, then do something else, then there is a way to kind of write conditional logic using Twig template. And for folks who use Jinja templates in Python, you would be familiar with the Twig syntax. And so it allows you to do some conditional logic by writing very, very little amount of code in the UI. And so I think, so those are like 7 different stock type of elements that are available that can be composed to create a UI. I think for most cases we have found they are just good enough, but if there are more needed, we can construct more stock elements. So far, I think we are seeing that these seem to be working out quite well. So let's go to our calculator app. And so we need a number element, so I'm going to go and add the number element. Takes a minute, and I'm going to say first operand, and I'm only going to allow one value here. And this is a type of command line argument, but you can also specify an environment variable if it happens to be that your app needs that, or a scheduler option, which is like a Slurm scheduler option, which need to pass on for some reason. You can do that. So command prefix in this case is, let me go back. Chunhan, can you prompt me a little bit here so I'm not spending too much time? What is it called? First.
Yeah. First on the bar, yeah, operator equal.
So this is my argument.
Unchecked, no. Okay, that's it. Yeah.
Okay.
Yeah.
Okay, so that's our first operator. We can set minimum and maximum value if you wanted to. Just for demonstration, I'm going to set the stepping as 1, so you can only enter integers. So essentially, when you do that, it's going to do the validation. It will complain that, oh, you're entering a real number. And then we are going to set required. That's good?
Yeah, same.
So there are a lot of settings here, but you know, and they're essentially to make the user interface more user-friendly. Every option can be very well documented. There's a whole lot of stuff there, but I think we'll leave that for later. And we'll just work with some minimal stuff here for now. Then we will add another, since we added one number, let's go ahead and add another number for now. The second operator, second operator, right?
Yeah.
Could you please watch for it that I'm actually...
Yeah, second on the operator. Yeah.
So that's the command prefix.
Equal, yeah.
And then I think we don't need to kind of write this in the cryptic language for the user interface. That can be a nice label there. And then again, we will force that this is an integer and make this a required field. You can send a message that why this is required. I'm going to ignore that for a moment. So we added a second operator. Now we are going to go add the
operand select. Yeah.
Because we want the ability for a user to select between multiple operators. So we are going to call
operand.
And then what is the prefix here?
Operand operand
and
equal.
operand equals, okay, and then
Yeah, uncheck. Yes, that's, and then go to
Then-
options.
and then options here, and I think this may be a little clumsy here, so you'll have to kind of
Yeah, yeah, options needed to type. Yeah, go.
I don't know if this will let me see the other side. So here
Yeah,
it's
plus.
and I don't need to type.
No. You just type the plus,
Okay,
not the sign at here. Yeah, key value probably, plus minus is not allowed. I mean,
Okay.
option key value is just a plus.
So oh, I see. Just mentioned
Yeah.
plus.
Yeah, plus.
Yeah. So there are,
all lowercase plus, all
Okay,
lowercase.
got it.
Key value is all lowercase. Yeah,
Got it.
plus.
So,
Yeah, minus. Yes.
and then I can change it.
Yeah, minus. Yes. Yeah,
this
text is
the
okay.
tricky
Yeah.
part. I think you'll have to kind of slide around the interface to be able to see the other side.
Multiply. Yeah.
R.
And divide.
And I'll show you an easy way to do that if this is becoming too clunky. We just enter something here so we get at least the scaffold going. And that's
No,
it.
slash, not percent.
Oh, sorry. Not the modulus, that's not going to work.
Yeah, modular.
Okay, all right, cool. So we got that. And now we obviously see that they are obviously not in the right order. So we want to kind of say, hey, the first operand goes first, the second operator goes third, and then the operand is in the middle. We can also say, hey, you want to probably name your job first, and then we save it. Okay. So
last one is output field, text field.
Oh yeah, we need one more. Good point. So we need one more operator here. Sorry, a UI element here. So we'll go ahead and add that. And
just output file name.
Output file name.
Command line output equal.
Output equals, okay.
Yeah, unchecked. Yeah, that's it.
And then this is also
required. Yeah.
And I'm going to rush up here a little bit. Okay, so that's done. Okay, so when this is done, and I think we would want to bring this up as well so it's in the right place. Want to show them in some form of order that makes sense to the user. And you can even hide this job resource part. You don't have to even display it, right? For some reason, if they don't need to see this, it can just be hidden. And okay, so now kind of go to the view and see how the user interface looks like. So we can go to the view. This is how it looks like. We can go back and alter this back and forth interactively while we are building the user interface. There's also a test thing that may or may not work correctly, but there's a test thing which fills in various things automatically. But sometimes it works, sometimes it doesn't work for certain apps, so you're not going to bother with that. But I want to quickly show you and see that that when we built this interface, it created this YAML for us. And then the key thing to kind of see, it will be a lot of other things, anything below the OSP app job resources, that was generated by the system for us, but these are the ones we added. So if you wanted to kind of, make the changes, let's say for operand or whatever, you can go ahead and make those changes here instead of trying to do all that through the user interface. So whatever is convenient, you can use either the user interface or you can use the markup in YAML to kind of build out these options. But it's probably a good idea to build out these things first time with the markup so you actually know all the markup, and then you're just tweaking the values and things like that. So you get this nice YAML and generated from that. And then essentially that's there to it. So we created our first application. And so we can go and go back, and I think we'll have to do one more thing here. So if I go to my apps, I will see my calculator for tutorial. I apparently created another one. And one more thing I have to do. Right now, this app is only available to me. Nobody else will be able to run it. But if I wanted to share this with everybody, I have to do this share with tenant. And so once I do that, then it's going to be available to everybody. Even though it may be listed for everybody, you won't be able to run it until I share it. So I'm going to go ahead and share it. And so let me see if I can launch this application. So if I launch this application, again, 5 times 5, let's just do that, and I'm gonna call it abc.text and essentially run this. So in a sense, what we did here is we already had our executable copied over to the system. We created a definition for it on the system, or sorry, on OneSciencePlace, assigned it where it's going to run. If you wanted to run on Expanse, you would have copied it there and just created the same interface. And then there would be few more things we would do to kind of specify the queue which it runs on. And I'll give you a flavor of that in one of the Expanse app real quick while this is running. So that's running. So we already have this Expanse app here. And I may have to switch to admin mode because I may not be able to edit it. Yeah, I can't edit it. So I'm going to switch to the admin mode real quick because I should have administrator rights there. And if I go and look at the edit form for application definition there, in that case, it's going to say it's a web application. It does few more things. It uses a Singularity container in that case. It uses Singularity run as the runtime. You get different options based on what you choose, Docker or Singularity. You choose that. Now this one uses a batch scheduler because Expanse is a batch system. And then we already have Expanse's batch profile that is already there. But if there is one not available for your system, you can actually create a batch profile. And it's pretty simple. It just takes few inputs. You kind of name the profile you want to call it, give it a machine name. And then you can enter commands like what the things the scheduler really needs to do to actually run the script. And these are essentially your module commands. What module needs to be loaded. So you kind of go and do that in this kind of scheduler profile. Then you provide a path for your Singularity file on Expanse. Specify the port where this application needs to run on. This is the not the host side port, but the other side, internal port. The OneSciencePlace will automatically find a port that is available on the host and kind of wire it to kind of run there. So that's important to kind of make it available on available on a port that can be changed. If you hard code it, only one application can run. So for example, if two applications launched an application on the same system, and if you have hard coded port, only one user can run it because that port is not going to be available. On Docker, it's more forgiving because Docker will rewire these things, but on Singularity, because there's no networking, the ports are shared between the host and the container. So you have to specify that. And then in this case, there's again a form that takes a password as an input. And that's essentially the app definition. I can show you the form as well here real quick. It only takes a password. So if you go and look at the build here, it only takes a password. If I go and edit the password, which is just a text field in this case, it says that this is the argument that the Jupyter notebook takes, is -- notebook.token and equals single tick and back tick, so it will quote it when a user enters something, and then that's how you construct the user interface. So if you go ahead and launch this app, this will actually run on Expanse on a shared queue. I think we have disabled other queues, but we can enable other queues. You can change the queue and run this. So since this is a batch system, we have some reservation on Expanse, so this job should run relatively quickly. So there's a little bit of a tricky thing about running interactive apps on a batch system. And again, when you run this thing, we are taking care of minting the SSL certificate for generating that URL. It's going to run on Expanse, and we will wire all that connection from Expanse and make it available over HTTP address. And so all that part is done by OneSciencePlace behind the scenes. So this will take few seconds to run. I think we have reservations, so this job should actually run. And we should be able to just see the Jupyter notebook like we were able to see earlier on the Linux host on the AWS system. So while this is running, let me see if there were other things we could kind of, so we are kind of running short of time now, so I wouldn't have time to kind of show adding a new system, but what we can do is we can review a system that's already there real quick. Let's start with the AWS system. So the AWS system, you kind of enter some preliminary fields about what the system name is, what the machine name you want to give, some summary about it. This could be a, a FQDN or an IP of the system, what the SSH port is. You specify whether this is going to use a common account or everyone is going to have their own account, what kind of system this is. This is only Linux system is supported. What is the root directory where when the jobs run, system will not allow any application or others to see, at least access things below this, or try to prevent things to kind of look below this area. So that needs to be chosen carefully for common account. For accounts which are controlled by user, this could simply be / because they should be able to see everything. Again, this is a script that needs to be copied. This is what magically does all that wiring about creating unique URLs, doing the ports and things like that. So that needs to be copied to the system. What runtime does the system supports, a Docker or Singularity? And you specify that, and then specify where the home directory for each user is going to be. If it's a batch resource, you'll specify, yeah, this can run the batch resource, and specify, a few other things. I don't think we'll have the time to open up that, but it's all documented. You can read up there how to create the batch style of things. And essentially that's there to it. And once you are done, what you will be prompted to, okay, now you have defined the system, go ahead and add a SSH key for the system. So since Chunhan created the system, I'm going to quickly masquerade as him and show you what that looks like. If you go to my account, and this only needs to be done for people who are creating the system. So this is not a normal thing which you would want every user to do, perhaps, but if you wanted to, they can do that. So if you go to system credentials, you can go and create a system credential. There are two ways to do that. You pick the system you want to kind of associate this key with. You'll get a list there. You can generate the SSH key, or you can use a pre-existing key. I sort of recommend generating this key because you don't have to worry about what formats to use and all that stuff. Also, since you're going to pair this key with this system, it's easy to kind of do something about it. If you want to remove it for some reason from the system, you can easily take care of that. So if you generate a key, you provided a nickname. I'm not going to assign it because it's going to break something here. You give a username, what the username is going to be for that system, and then it will generate a key. And what it will do, it will give you just the public key. The private key is not available to the administrator. It's going to go and store it in HashiCorp Vault, which is running on Amazon for us with the Tapas backend, and it stores there. And it will only give you the public key. And the idea is you take that public key, log on to the system, and add it to the system, so that now the system has access. So that's something which either needs to be instrumented through scripting when you are constructing a portal, or if a user needs to do that, they already have access to the system, they need to stick this public key into their account. Or if they already have a key, add that private key here, so it can be then safeguarded by the gateway. So once you define a system, then it will become available to be paired with any application. And then you can, when you construct an application, you can select an app. And I think once you add a credential, there is a button there where you can check the credential to make sure that the SSH credential is working properly before you kind of go about doing other things on top of it. So I think we are just reaching at the end of time here. I just wanted to kind of give you a flavor of publication before we adjourn. And maybe field a few extra questions if Claire's allows us a few more minutes. So publications on OneSciencePlace are first-class objects. You can actually specify authors, get PIDs, and get a DOI, and share data or other artifacts and describe them in a fairly compelling way and make them available. And to create a publication is a fairly straightforward process. For some reason, I don't have an ability to create a publication here, but let me see if I have it here. Oh no, I think it's the menu is missing, so I'm gonna create it in a different way. So creating a publication is just a form. You select what type of publication it is. You essentially enter a web form. You can search for your name through, Orchid. Sometimes it works, sometimes it's easier to type in, because this is basically essentially doing autocomplete from Orchid API. So sometimes it works nicely, sometimes it doesn't. And you can add multiple authors. You can mint a DOI or an ARC or a handle. Different kind of persistent identifiers are supported. You can enter a sponsor for your work. You can enter who is the publisher, if there is one, what kind of rights you have, what kind of license you want to pick. These can be configured for each gateway. I think there are 500 stock licenses that are available. You can pick and choose and make some of them available. We can add custom licenses. Those can those could be made available as a drop-down. You can add references to the work and add any related URLs and things like that, add any keywords and things like that. And it goes through, we can configure the publication process to be just immediate, or it can go through a moderation process where a draft is created, then it's passed to a moderator for reviewing, and then the moderator either sends it back for the contributor to kind of revise it, or when it's satisfactory, it can be published. So this is an optional moderation pipeline that's available that can be configured, and these stages can be defined to be a little different. Now, the idea is that we created these applications. Applications are also first-class publications in OneSciencePlace. We don't have these fields mapped to applications, but all these things will be available in an application. So once an application is created, it can be referenced with a DOI, for example, or an ARC or a handle, a persistent identifier. It can be a citable application and is available for others to kind of cite it in their scholarly articles, that this is what was used to kind of run certain application on this and this gateway or a portal. So with that, let me kind of pause here and hand it back over to Claire, and see if we can field some questions if there's time, or we can extend some time.